Welcome economic students. This is part 2, second installment of video lecture series investigating international trades, the U.S. and global economy. If you've not yet watched part 1 of this video series, highly suggest you watch part 1 prior to moving on to this second installment. So the Hatfields and McCoys, maybe you've heard of them, two American Appalachian mountaineer families who, with their kinfolk and neighbors, engaged in what was known as a legendary feud. Apparently, it attracted nationwide attention in the 1880s and 1890s, and even prompted judicial and police action. Who knows the reason behind this? You know, some of it's myth, some of it's legend, yada yada yada. But it does say that their bitter dispute actually ended up somehow going to an appeal all the way to the Supreme Court. All we know is these two families don't like each other, so let's investigate their situations and then learn some economics from the Hatfields and McCoys. The Hatfields and McCoys don't talk to each other very much. They would rather shoot than smile. The Hatfields are better off than the McCoys in every way. So we're going to introduce two important economic principles. The first one is called absolute advantage. It tells you in line 2 here, third sentence, the Hatfields are better off than the McCoys in every way. When we investigate their economic situations, we're going to discover that the Hatfields have an absolute advantage in producing both products in question. Why? Why it takes only 8 hours for one Hatfield to grow 1 corn, and it only takes 10 hours for one Hatfield to make 1 yard of cloth. The McCoys aren't any more or less shiftless than the Hatfields, but their land is worse and their tools aren't as good. Anyway, it takes 15 hours for one McCoy to grow a bushel of corn and 12 hours for one McCoy to make a yard of cloth. The McCoys are worse off than the Hatfields because they have to work longer for everything they want. Now, old Ma Hatfield is a sly one. She's been sitting and rocking and thinking for years. One day she says, Pa, I've been cogitating. You know what I think? I think we'd be a whole lot better off than bear varmints. We stop fighting the McCoys, and we spend more time raising corn and trade it with the McCoys when we need cloth. Paul spat. Darn it, woman, he said. We are better farmers than their varmints and better weavers, too. Besides, I don't want to be dependent on that poor excuse for a family for my clothes. Can you help Mom and Pa settle this? Using worksheet. Well, we're going to do better than a worksheet. Here we've outlined the economic situation of the Hatfields and McCoys. All right. So there are two products in question here, corn and cloth. And there's two economic participants, Hatfields and McCoys. First idea we're going to introduce is what Adam Smith referred to as absolute advantage, sometimes defined as a nation being able to produce more than its potential trading partner, or produce in higher volume than its potential trading partner. So, how long does it take Hatfields to make a bushel of corn? 8 hours. Versus the McCoys, it takes 15 hours. So obviously, in absolute terms, the Hatfields can do this better. How about cloth? Well, as the story tells us, it takes the Hatfields 10 hours to spin a yarn of cloth, and it takes the McCoys 12 hours. So again, the Hatfields are better in absolute terms at producing this product. But what if Ma Hatfield is onto something? What if the nations concentrate their economic resources and efforts into producing the product without which they enjoy an absolute advantage, but what David Ricardo, unlike Adam Smith, refers to as a comparative advantage? What if both countries, in this case both families, specialize? So, if we look at the ratio or the relative dominance of the Hatfields when you look at corn versus cloth. Now, don't tell your English professors we said this in economics class. Where are the Hatfields more better? Well, they're more better at corn. 8 hours versus 15 hours. They're almost twice as fast, right? They can do it. Poor McCoys almost takes them double the time to make corn. With cloth, it's the opposite. the McCoys are less worse when it comes to producing cloth. Now again, the Hatfields have the absolute advantage in corn, 8 hours versus 15 hours. The Hatfields have the absolute advantage in cloth, 10 hours versus 12 hours. But Adam Smith actually made a mistake in his famous book, The Wealth of Nations, suggesting that nations should only consider trade based on what he referred to as absolute advantage. Along comes David Ricardo sometime later and introduces this idea of comparative advantage, which we're going to investigate in much more detail. If both families, the Hatfields and McCoy, concentrate in producing a product in which they have the comparative advantage, the Hatfields are more better at corn. The McCoys are less worse at cloth. So you can see I highlighted this for you. Hatfields red, corn red. Hatfields have the comparative advantage in corn. McCoys dark blue, cloth dark blue. The McCoys, even though they're absolutely worse at both, actually have a comparative advantage in cloth. They're less worse at cloth. Now, what does BT, AT, and GFT mean? So before trade, both families would go through the bother of making one of each of these products. So if the Hatfields made one corn and one cloth, it would take them a total of 18 hours. If the McCoys went through the same economic exercise, one corn, one cloth, it would obviously take them 27 hours. But what if they listened to Ma Hatfield? What if each country specializes in producing the product in which they enjoy a comparative advantage and trades for the other product? So instead of producing one of each, as they were before trade, both families will only produce one product, the one in which they have a comparative advantage, and trade for the other product. The Hatfields will just make corn and trade for cloth, and vice versa. The McCoys will just make cloth and trade for corn. So after trade, what happens? The Hatfields spend a total of 16 hours working. Why? They make 2 corns and they will trade for 1 cloth. The McCoys, they end up working 24 hours. They're just making cloth. They'll make 2 of them. 2 times 12, 24. The magic is the last column, gains from trade. Now we're going to demonstrate this more mathematically later on when we talk about production possibility frontiers and escaping limitations of domestic production. But for now, you can see that both families are made better off through specialization in trade based on comparative advantage. And what's most amazing is the McCoys, who were worse off at both products, actually end up gaining more than the Hatfields. Our anecdote of the Hatfields and McCoys introduced the 2 principles developed by economists to discuss and evaluate international trade, specialization, and trade. The first, 1776, Adam Smith, Wealth of Nations, absolute advantage. Along comes David Ricardo sometime later, 1817, offers a new theory on trade based on not absolute advantage, but what he called comparative advantage. So we're going to discuss these 2 theories in more detail using several other examples. Then we will discuss the calculation of comparative costs to determine which nation has a comparative advantage, building on the principles of the production possibilities model covered earlier in the course. We will reason why nations are and citizens of the globe are made better off through specialization and trade. And then, of course, we will talk about the terms of trade. If nations are going to agree to specialize their economic production into a certain type of output, they're going to want something in return, and we're going to calculate and demonstrate how terms of trade are managed. So absolute advantage. There's a few different versions of this, but the most straightforward one is economy's ability to produce more of another good than its potential trading partner. Comparative advantage is a little more mathematical in its interpretation. Instead of just being able to produce more than your potential trading partner, comparative advantage is an economy's ability to produce a good at a lower opportunity cost than your potential trading partner, another country. So if you remember when we covered production possibility frontier, we measured opportunity cost of the production of one good in terms of what needs to be given up in terms of the other good. So we're going to revisit this idea of calculating opportunity cost, and then we're going to employ it to demonstrate comparative advantage and reason why one country should specialize in producing a certain product and trade for the other good based on comparative cost. We're going to start off with a simple example. Two little countries. One's called the Crew and one's called the Islanders. So think of these as little island nations, and we're going to discuss potential production of two simple products. They're isolated and they only produce huts and radios. All right. Now for the time being, we're going to assume that the Crew does not know the Islanders exist and vice versa. The Islanders are unaware of potential trade with the Crew. So given their scarce land, capital, and labor, we are able to construct the Crew's production possibility frontier. So a couple assumptions. Number one is that this represents the Crew's production possibility frontier for 1 month worth of economic activity. All right. Now, we're also going to assume that because they're isolated and they don't have the potential or the possibility of acquiring more resources, that they're going to be stuck at this production possibility frontier for the foreseeable future. All right. Now, likewise, something about the shape of the production possibility frontier tells us an economic story, and we see right away that this is a linear production possibility frontier. This will be an assumption we employ when we study international trade, because this is an introductory class. So if you took an international trade course, you would build on this simplistic model with much different and complicated, we'll say, alterations to the simple model. So for simplicity, we're going to say that every country we evaluate will be dealing with a linear production possibility frontier. Now, what does that mean? You may remember this from production possibility curve study earlier in the term. When a production possibility frontier is linear, it means that there is a constant cost along the curve. In other words, what must be given up, what one must give up to acquire the other product remains the same along the production possibility frontier. All right, as opposed to a production possibility frontier that has concavity to it. So this is straight. So what we're saying here is that every time the Crew wants another radio, it's going to cost them the same number of huts. And every time the Crew wants another hut, it's going to cost them the same number of radios. So the ratio remains the same along the entire production possibility frontier. Now remember, we said that in a macro economy, if we were evaluating an entire nation's economic output, the production possibility frontier would be curved or have concavity because we believe that economic resources are not readily shiftable or adaptable. So we're going to forego that sort of assumption right now. We're going to keep it simple. Likewise, when you talk about huts and radios, we'll say, okay, they're not all that different in a productive capacity. Now, it already says this on the slide here, the opportunity cost of a radio and the opportunity cost of a hut. But can you calculate this before I tell you, right? In other words, where are we coming up with these numbers? How do we determine what the opportunity cost of huts were in terms of radios? How many huts does the Crew need to give up to get a radio? And likewise, how many radios did they have to give up to get a hut? Well, here's what we're doing, right? If we said, all right, what if this nation put all their economic resources into making huts? Well, in 1 month, they make 120, that point on the vertical axis at the top of their production possibility frontier. If they changed their economic mind, if they changed their allocation of resources and said, you know what, the heck with huts, we'll just make radios, they could crank out 20, right? You're just inside 21 there, right? Now, obviously, if they were going it alone and they had no chance to trade, they had no potential to trade, they would most likely want to produce somewhere in the middle, some combination of huts and radios. But we can still use these extreme numbers to help us calculate opportunity costs because it tells us that linear production possibility frontier, constant cost along the curve. So what if the crew said, let's give up all 120 huts to get 20 radios? 120 divided by 20 is 6. So the opportunity cost of a radio is 6 huts. Each time the crew wants a radio, they have to give up exactly 6 huts. To calculate the opportunity cost of the other product, in this case huts, you simply invert the fraction. 20 over 120, 1/6. Therefore, every time the crew wants a hut, they have to give up 1/6 of a radio. Now, I know in your mind you might be saying, what the heck is 1/6 of a radio? That makes 0 sense. All right, obviously, 1/6 of a radio doesn't mean we take a radio and we split it into sixths. All right, but you get the idea. All right, so keep this in mind because we're going to move on to the Islanders. The most huts the crew can make is 120. The most radios they can make is 20. They'll probably want some combination of both. If they did not ever consider trade, they would produce at some point on their curve between huts and radios. Here's the Islanders. What do we notice? The Islanders, given the same assumptions, can only produce 90 huts per month. And the crew can, and the Islanders can only make 10 radios per month. So we make an Adam Smith absolute advantage observation immediately. All right. In absolute term, the crew can make more huts per month, 120 versus 90. In absolute terms, the crew has the absolute advantage of making huts. All right. In absolute terms, the crew can make far more radios than the Islanders. They can crank out 20. The Islanders can only make 10. So when we think about the Adam Smith version of trade and the economic rationale for trade, he would suggest there's no reason for these two nations or two countries to consider trading. In absolute terms, the crew has an absolute advantage in producing both huts and radios. But along comes David Ricardo and says that's not the mathematically correct approach to determining international trade and specialization. He suggests let's use comparative costs. What's the opportunity cost of each product in each country? And if it makes sense to trade, it will be based on these comparative costs. So using the same mathematical logic, we can calculate the opportunity cost of a radio for the Islanders is 9 huts. Why? 90 over 10. The most huts they can make is 90. The most radios they can make is 10. If they give up all 90 huts to get 10 radios, 90 over 10, 90 divided by 10 is 9. So every time the Islanders wants a radio, they have to give up 9 huts. Remember, the crew only had to give up 6. So the crew has a lower domestic opportunity cost when it comes to making radios. All right, each radio only costs 6 huts. The Islanders, it costs 9 huts. But look what happens when we calculate the opportunity cost of a hut. For the Islanders, a hut only costs 1/9 of a radio, which is lower than the 1/6 of a radio that it costs the crew. The opportunity cost of a hut is lower for the Islanders than it is for the crew. Now, this was the mathematic genius of David Ricardo. Not only did he introduce the idea of comparative costs as the basis for trade, he proved mathematically that it is a statistical impossibility for a nation to have the comparative advantage in producing both products. Just like the Hatfields and McCoys, right? The Hatfields couldn't be more better at both. The McCoys couldn't be less worse at both. In this case, the Islanders have the absolute advantage in producing huts and radios, but they only have the comparative advantage in producing huts. The Islanders enjoy the comparative advantage in radios when we use comparative costs to calculate this particular basis for trade. Now, we still have to determine an important economic outcome. All right, let's assume that Ricardo's right. The crew should make radios. How many will they make? They'll make 20 because it's the maximum they can make. The Islanders will make huts. How many will they make? They'll make 90. That's the maximum they can make. Both countries are still restricted by their production possibility limits for the month, but they're going to concentrate their economic efforts into producing the product in which they enjoy a comparative advantage. They're going to trade for the other product, but we still have a big question to answer. So terms of trade is what we have to calculate, figure out, determine. So in our little example, we have the crew and the islanders. We already determined that based on comparative cost, it makes economic sense for the crew to make radios and for the islanders to make huts. We also know that the crew will just specialize their economic resource into making the radios, and they will make 20 because that's the maximum they can produce based on their production limitations displayed by their production possibility frontier. And the islanders will make 90 huts. But what about the exchange rate? How many huts does the crew expect for a radio, and how many radios do the islanders expect for a hut? Well, that's what we mean by the terms of trade, the rate of exchange. How many of X for Y and Y for X? So the idea is pretty straightforward. In other words, if you're going to engage in specialization, you're going to trade for another product, you're obviously going to want something in return, and the terms of trade is just the numerical calculation or representation of how many will you get in return. More importantly is, how do we determine the terms of trade, the limits, right? Now this should make economic sense to you if you're following along. A country won't make themselves worse off through trade, right? So they would only trade if the terms of trade are superior to what was taking place domestically prior to their consideration of trade. So if you're the crew and you think, okay, the opportunity cost of making a radio is 6 huts. Well, we're not going to accept anything less than 6 huts in return for our radios. And if you're the islanders and say, okay, well, the opportunity cost of making a hut is 1/9 of a radio. Well, okay, then I'm going to want something better than that in return for my economic efforts, right? Which leads to this important idea. So put a star next to this, a little note in your notebook, that when we determine what the exchange rate will be, what the limitations of the terms of trade will tell us is that they must lie between the respective domestic opportunity cost of production of each country, right? So it's just a numbers game. In other words, you wouldn't make yourself worse off through trade. So if you say, you're the islanders, all right, we're just making huts. The opportunity cost of a hut is 1/9 of a radio. Well, why would we engage in trade if we're not going to receive back at least what it used to cost us to do it domestically, right? And the same thing for the crew, right? And this will be the same principle that will be used throughout the remainder of our analysis of comparative costs, specialization, and trade. The terms of trade must always lie somewhere between the respective opportunity cost of production of the two products in question and the two countries. Economics is all about doing the best with the least, right? Limited economic resources, unlimited economic wants. The definition was stressed in the beginning of this course. The very field of economics exists because land, capital, and labor are scarce relative to the desires and wants of human beings. The production possibility frontier of any country represents limitations of production at the moment because of scarce resources and fixed technology. So limited resources in quantity and quality, and fixed technology, a set of technological rules that we must play by until some technological advancement comes down the road, means that we would never be able to consume beyond our domestic production possibility, beyond the frontier which represents our productive limits. However, look what happens through trade. Right? Economists believe this is some type of economic miracle. Both countries take their limited or scarce resources, concentrate production in the product in which they enjoy a comparative advantage based on comparative costs, trade for the other product, and both countries are made better off. If you look at the point here, this orange point that lies outside the production possibility frontier for the crew's production possibility frontier, we would call this desirable but what? Unattainable prior to trade. But the magic of trade means that more consumption is possible because more production takes place through specialization in trade. Now, in economic terms, we say that we lessen the burden of scarcity. Right? Economists believe that specialization in trade actually raises the standard of living for citizens across the globe. And obviously it doesn't just benefit the one country, it benefits the other nation. Again, the reasons why economists believe that trade is good, the economic gains from trade include three ideas: increased world output, more efficient use of scarce resources through specialization in trade means there's simply more consumption available to all citizens, which leads to a higher standard of living. And then it addresses the very heart and soul of economics, the idea that scarce or limited resources relative to human wants, specialization in trade reduces the burden of scarcity. So here we have two nations, Absoluteville and Comparoland. We are evaluating their production possibility frontiers based on the potential output of two products, corn and rice. We can see the table up top represents output, economic output for these two products for each country, A, B, C, D, E, and F, the points on the curves. And we can also see this information graphically on the graph below, the production possibility frontier below. The nice thing about this graph is that both countries are represented on the same graph. So the red production possibility frontier is Absoluteville. The blue production possibility frontier is Comparoland. Now, before we even discuss numbers, the beauty of graphing both countries' production possibility frontier on the same graph is that you can visualize many of the economic concepts that we were discussing mathematically before, right? So again, rice production on the vertical, corn production on the horizontal. We can see that the red production possibility frontier lies outside the blue production possibility frontier in both the production of corn on the horizontal and rice on the vertical. Therefore, Absoluteville has an absolute advantage in producing both products. No surprise. All right, so I highly suggest, if you're ever given one of these problems, to calculate these ideas, these economic concepts on a quiz or a test. Draw both nations' production possibility frontiers on the same graph, and you will never miscalculate, you'll never misrepresent, you'll always easily identify both absolute and comparative advantage. Now, we know that Absoluteville has the absolute advantage in producing both products. 25 total bushels of corn possible for Absoluteville if they just concentrate their land capital and labor into producing corn. All right, poor old Comparoland could only make 10 per month if they just made corn. If Absoluteville decided they didn't want to make corn, they just wanted to make rice, they could crank out 50 bushels of rice at point A. All right, if Comparoland attempted the same idea where they said, look, let's not make any corn, let's just make rice, they can make 30. So in absolute terms, Absoluteville can produce more. Now, what about comparative cost? What about comparative advantage? Again, the visualization really helps here. Look at how much further out the corn production of Absoluteville is relative to Comparoland, right? 25 versus 10 at point F as in Frank on both nations' production possibility frontier. 25 is 2.5 times as large as 10. So Absoluteville is dwarfing it. They're just crushing it when it comes to corn production relative to Comparoland. Now, again, Comparoland still produces less in total terms when you talk about rice production, but 30 at point A on their curve versus 50 for Absoluteville on their production possibility frontier. They're not quite as far behind when it comes to rice production, right? So we know that both countries should concentrate their limited or scarce economic resources, their land capital and labor, into producing the product in which they enjoy a comparative advantage and trade for the other product. So in this case, Absoluteville should make corn and Comparoland should make rice. All right. Now the opportunity cost of each product is calculated on future slides to verify this information, but the visualization helps us. Before we leave this picture, let's also comment on one other idea. Remember, after both countries agree to trade based on comparative costs, they will specialize their economic efforts into producing one product and trade for the other product. So Absoluteville has the comparative advantage in making corn, and Comparoland has the absolute advantage in producing rice. So in total, there will be 25 bushels of corn produced by Absoluteville and 30 bushels of rice produced by Comparoland. Now, these totals might seem small, but in the real world, they could be in millions of tons. We went over this information on the previous slide, but it's good to reinforce the ideas, and we can do it quickly. We have Absoluteville and Comparoland's total production for rice and for corn, and it demonstrates here that same information we calculated by the visualization. Absoluteville has the absolute advantage in producing both products. Absoluteville can produce 50 bushels of rice per month relative to poor old Comparoland only 30, absolutely more. When it comes to corn, Absoluteville can crank out 25 bushels per month. Poor old Comparoland can only crank out 10. Again, Absoluteville has the absolute advantage in producing both products. Okay, we already calculated this visually using the production possibility frontiers below. Let's prove it mathematically. How do we know that Absoluteville has a comparative advantage in corn and that Comparoland has a comparative advantage in rice? Well, we use simple math to determine the opportunity cost of each product in each country in terms of the other product. So let's assume that Absoluteville never had a chance to trade, and they wanted to know, okay, what's the opportunity cost of corn in terms of rice, or rice in terms of corn? Every time we increase corn production, how much rice do we have to give up? Every time we increase rice production, how much corn do we have to give up? Let's say we start at point A as an apple on Absoluteville's red production possibility table up top. Moving from A to B, corn production increases from 0 to 5, and rice production falls from 50 to 40, right? Whatever you're getting, put that on your denominator. Whatever you're giving up, put that on your numerator. Rice production fell by 10, so 10. Corn production increased by 5 over 5. The opportunity cost of each bushel of corn is 2 bushels of rice, right? We know this because the production possibility frontier is linear. This opportunity cost will remain the same along the curve. If you don't believe me, let's say we start at point A as an apple and move all the way to point F as in Frank, right? In this case, we give up 50 bushels of rice, because rice production goes from 50 at A all the way down to 0 at F to get 25 bushels of corn. 25 on the denominator, 50 on the numerator. 50 divided by 25 again is 2. Right? Now this only is true if our production possibility frontier is linear, that we can use any 2 points. To calculate the opportunity cost of a bushel of rice, we simply invert the fraction. Instead of 2 over 1, it's 1 over 2. But if you want to do it the long way, let's start at F as in Frank, where rice production is 0, corn production is 25, and move back to E as in everyone. How do we calculate opportunity cost of a bushel of rice? All right, well, we get 10 rice, that goes on our denominator. We give up what? 5 corn, 5 bushels of corn. 5 over 10 is 1/2. 1/2 is obviously the inversion of 2 over 1, right? So that's how we calculate opportunity cost for each product. Using the same logic that we employed for Absoluteville, we can quickly calculate the opportunity cost of corn and rice in Comparoland. If we start at A as an apple in Comparoland and move to B, corn production goes up by 2 from 0 to 2. Rice production falls from 30 to 24, right? 6 over 2, the opportunity cost of a bushel of corn in Absoluteville is 3. Inverting the fraction, the opportunity cost of a bushel of rice is 1/3 in Comparoland. This helps us, this little table helps us determine then who should produce what product, right? Who has the comparative advantage in each product? Well, we just did the math here, and now we're just going to revisit and reinforce and then make certain we're all still on the same page. All right. Absoluteville has a lower domestic opportunity cost when it comes to the production of corn, because 1 bushel of corn costs 2 bushels of rice. In Comparoland, 1 bushel of corn costs 3 bushels of rice. Absoluteville has a comparative advantage in corn. They should produce corn. When you look at rice production, Absoluteville, it costs them 1/2 of a bushel of corn. It only costs Comparoland 1/3 of a bushel of corn to get a bushel of rice. Therefore, Comparoland has the comparative advantage in producing rice. Both nations should specialize in producing the product in which they have a comparative advantage and trade for the other product. Now, we already determined this by looking at the graphs, but we also know now what will total production of each product be. Now, what about calculating the gains from trade, the whole purpose of our little exercise here? First, we know that allocative efficiency, that's a normative decision. In other words, countries will determine what mix of output maximizes their happiness by weighing the marginal benefits and marginal costs of production and consumption. How our resources used most efficiently is really determined by society's happiness for capital goods versus consumer goods, or leisure time versus work. So there's a lot that goes into this allocative efficiency. This idea is normative. It's subjective, okay? Now, prior to considering specialization in trade, both nations can produce some of both, right? So prior to the possibility of trade, Absoluteville would produce some corn and some rice, and Comparoland would produce some corn, some corn and some rice, all right? Now, to calculate gains from trade, we're going to represent 1 point on each production possibility frontier as allocatively efficient. Notice here it says that point must be given. In other words, if you just looked at each nation's production possibility table and their curves that graphically represent these tables, you could never just guess at which point was allocatively efficient. You'd have to be told, right? Because again, it's subjective. The citizens of that country weigh the marginal benefits and marginal cost of producing and consuming the next unit of output. It would have to be given. So it tells you in this problem, let's assume Absoluteville was allocatively efficient at point D as in dog, where they're producing 15 bushels of corn and 20 bushels of rice. And before trade, Comparoland, they were happy, they were ecstatic at E as in everyone, 8 bushels of corn and 6 bushels of rice. Before we go any further, let's calculate total world production before trade. Right, Absoluteville was allocatively efficient at D, 15 corn, 20 rice. Comparoland, E as in everyone, 8 bushels of corn, 6 bushels of rice. Well, 15 and 8, where did I get that number? Absoluteville produced some corn, Comparoland produced some corn prior to trade. That's not going to be the case after trade, but prior to trade, each country produced some of both. So prior to trade, there was 23 total bushels of corn produced. Prior to trade, what was total rice production? 20 bushels of rice produced in Absoluteville, 6 bushels of rice produced in Comparoland, 26 bushels of rice. So remember, allocative efficiency must be given to you. It's a normative decision. Absoluteville and Comparoland, they determine this based on the marginal benefits, marginal cost. Right? It's subjective by nature. Citizens of this country weigh how would we like to allocate resources towards between the production of corn and rice. So we said in this example, let's assume that Absoluteville was allocatively efficient at D, 15 bushels of corn and 20 bushels of rice. This was the mix of output that maximized society's happiness. And Comparoland, they were allocatively efficient at E, E as in everyone, 8 bushels of corn and 6 bushels of rice. Right? That's where the next bushel of rice production, the marginal benefit exactly equal the marginal cost of how resources could have been used otherwise. All right, now remember, that has to be given to you. You can never determine that on your own. But now whether we do understand that Absoluteville was allocatively efficient at D as in dog, and Comparoland was allocatively efficient at E as in everyone, we can calculate the gains from trade. We can now calculate gains from trade. The red represents production of each product before trade. Before trade, Absoluteville and Comparoland needed to produce some of both products because the possibility of trade did not exist. After trade, nations will concentrate their limited or scarce resources and trade for the other products. Absoluteville will just make corn. Why? Because they have a comparative advantage in corn. Comparoland will just make rice. Why? Because they have a comparative advantage in rice. All right? But before trade, when they each produced some, total output was 23. All right? Absoluteville produced 15 bushels and Comparoland produced 8 bushels. After trade, what happens? Well, rice production goes up from 23 to 25. Notice two things here. Rice production increased. Also notice Comparoland is not making any of this product. Rice production also increased. Prior to trade, Absoluteville made 20 bushels of rice and Comparoland made 6 bushels of rice for a total of 26. However, Comparoland agreed to just produce rice and trade for corn. Notice Absoluteville is not producing any corn anymore. 0 for them after trade, the green column down bottom. Comparoland, producing 30, actually produces more than the total of both countries doing it separately before. Rice production increases from 26 to 30. So the beauty of this example is that it helps us emphasize the reason why economists believe free trade is beneficial. Increased total world output, increase in standard of living, lessens the burden of scarcity. The next step then is to introduce the reasons why nations sometimes fight against trade, the reasons why and how they take measures to interrupt what would be otherwise free trade. Okay, economics students, time to put your knowledge to the test. Last example of specialization in trade. Here we have two countries, Canada and Belgium, and we're graphing their production possibility frontier for 1 month, and we're representing two products, chemicals on the vertical axis and wheat production on the horizontal axis. Chemical production on the vertical, wheat production on the horizontal. Canada is the blue production possibility frontier, Belgium is the gray production possibility curve. What do we notice? We can make some general economic observations immediately. First, both production possibility frontiers are linear, which means what? Constant cost along the curve. Anytime a production possibility frontier graphs as a straight line, it's linear. The trade-off of one product in terms of the other product, the opportunity cost will remain the same along the entire curve. All right, the economic rationale behind constant cost along the curve, that the production of these two products is not all that different, and therefore it is relatively easy to shift economic resources between production of these two types of output. Now again, this is an introductory course. If you take international economics at a later date, we will relax some of these assumptions and we'll investigate international trade in much more detail, assuming that some of our simplistic explanations have changed. But for now, this is a survey course, you get the idea. Now, what about the Adam Smith version of economic reality? Who can produce more? Who has the absolute advantage? Which nation can produce more chemicals and which nation can produce more wheat? Obviously, the blue production possibility frontier, representing Canada's economic output, lies outside of the gray production possibility curve, representing Belgium's economic output. So Canada has the absolute advantage in both chemicals and in wheat. But notice the difference. In other words, where does Canada trump or dominate? Where are they really showing their flexing their economic muscles? And where is Belgium not falling too far behind? Why is that important? David Ricardo, his idea is that even if a country, in this case Canada, has an absolute advantage of producing both products, it still makes sense for one country to take their limited land, capital, and labor, their limited scarce resources, and concentrate their economic efforts in producing the product in which they enjoy the comparative advantage and trade for the other product. So in this case, Canada will have the comparative advantage in wheat. And by default, Belgium will have the comparative advantage in chemicals. That's the beauty of David Ricardo's contributions to economic thinking in regards to international trade. It's impossible for one country to have the comparative advantage in the production of both types of output. Let's reinforce our economic observations from the production possibility frontier using the data of the production possibility curves for both countries, Belgium and Canada. Let's look at wheat production, right? Canada can produce 20 tons of wheat per month. Belgium can only produce 12. Absolute advantage, Canada. Canada can produce 60 tons of chemicals per month. Belgium can only produce 54. Absolute advantage, Canada. What about comparative cost? What if we calculate the opportunity cost of wheat in terms of chemicals, and of course the opportunity cost of chemicals in terms of wheat? The trade-off, every time one nation wants more of one, what do they have to give up in terms of the other product? Let's use comparative cost to calculate which country has a comparative advantage in producing each product, and therefore how they should specialize their resources and trade for the other good. All right, let's look at Canada first, down bottom, and say, what's the opportunity cost of a bushel of wheat, right? Okay, well, if we start at point A as an apple, producing 0 wheat, and we move to point B as in boy, wheat production rises by 2, chemical production falls by 6. 6 divided by 2 is 3, so each bushel of wheat costs 3 tons of chemicals. Let's do the same analysis for Belgium. Start at point A as an apple, move to B as in boy. Wheat production increases from 0 to 2. Chemical production falls from 54 to 49. 9 divided by 2, 4.5, 4.5. The opportunity cost of a bushel of wheat is lower in Canada, 3 versus 4.5 where it is in Belgium. We already saw this graphically, but the math is reinforcing our economic observation. Canada has a lower domestic opportunity cost in wheat production. Every time they want some wheat, they have to give up fewer chemicals than Belgium. Right? We already know this mathematically because of David Ricardo's brilliance and genius, but we're going to prove it just to make sure you understand. By default, even though Canada had the absolute advantage in producing both products and has the comparative advantage in producing wheat, Belgium must have the comparative advantage in producing chemicals. Right? So let's calculate the comparative advantage. Well, we can invert the fractions, right? We can simply say, instead of 6 over 2 and 9 over 2, we can say 2 over 6 and 2 over 9, right? But make sure you understand where the numbers are coming from. Let's start at point K as in Kelvin or Kelly, all the way on the right for Canada's production possibility frontier, where they're producing 20 tons of wheat and no chemicals. And now they want some chemicals, all right? So chemical production increases from 0 to 6 when we make a marginal decision to change production output from K to J. All right, and wheat production falls by 2. So what happens? You get whatever you're getting, put on the denominator. Whatever you're giving up, put on your numerator. 2 over 6 is 1 over 3 is 1/3. Do the same analysis for Belgium. All right, Belgium was producing at point G as in good, 12 wheat and 0 chemicals. Right, moving to F as in Frank, chemical production increases to 9. Wheat production falls by 2. 2 over 9 is 0.22222, which is less than 1 over 3, which is 0.33333. Again, the math supports our observation from our production possibility curve. Belgium has a lower domestic opportunity cost when it comes to chemical production. The opportunity cost of producing chemicals in Belgium is lower than Canada. Belgium has to give up fewer bushels of wheat per unit of chemical production than does Canada. So we now know that each country should specialize in producing the product in which they enjoy the comparative advantage and trade for the other good. So in this case, Belgium will only make chemicals. How many will they make? Well, with their limited scarce resources, capital, land, labor, entrepreneurs, they will be able to produce 54. Where did we get that? Point A on Belgium's production possibility frontier. Belgium can produce 54 units of or tons of chemicals. Canada, they will just make wheat. They will produce at K as in Kelvin, right? K as in keep. They will produce 20. All right. Now we have to calculate the last piece of this, the possibilities of zones. Why is it? Why is it that we're doing this? This whole exercise. Economists believe that specialization in trade makes nations better off, reduces the burden of scarcity. Right? Global output increases. Notice D as in dog is highlighted in red on Belgium's production possibility frontier, and G as in good is highlighted in red on Canada's production possibility frontier. Why are these points highlighted? This represents allocative efficiency for each nation prior to considering specialization in trade. So prior to trade, each nation had to produce some of both products. Belgium was producing 6 wheat, 27 chemicals. Canada was producing 12 wheat and 24 chemicals. So let's add up total production prior to trade. All right, 6 wheat produced by Belgium plus 12 wheat produced by Canada comes out to 18. What's total production now? Well, Canada is specializing in the wheat production. They're just producing this product. They're producing 20. So wheat production went up by 2 from 18 to 20. All right. What about production of chemicals? Well, Belgium was producing 27 at point D as in dog. Canada was producing 24 at point G as in good. 27 plus 24 is 51. Belgium will concentrate their limited scarce resources, their land, capital, and labor, into producing a product in which they enjoy the comparative advantage, and they will just make chemicals. That's 54 at point A on their production possibility frontier. So chemical production went from 51 to 54, an increase of 3. Just as economists suspected, right, the magic of international trade, the economic marvel of specialization in trade. Each nation is better off through specialization in trade by taking their limited or scarce resources, concentrating their economic efforts in producing the product in which they enjoy a comparative advantage, and trading for the other product. Right? Global output went up. Right? Each nation is now consuming at a point beyond their domestic production limitations, and the standard of living of each citizen in both countries increases, or is better off. But in the real world, is everyone happy? Well, let's just think about this simple example. Who's not happy in this simple example? What if you were a manager at the chemical production facility in Canada, and all of a sudden there's not as many jobs, or maybe no jobs associated with that particular industry because it got offshored to a different nation, right? Same goes for Belgium. What if you were involved with the wheat trade, right, in some capacity? Whether it was you somehow were involved with storing the wheat or distributing it, or perhaps you were just a trader on the floor there, right? Perhaps your job was dependent completely on wheat production in Belgium. So therefore, you're now kind of SOL, out of luck, right? You're out of luck. What can you do? All right. Now, that's why the next phase of our economic analysis is going to discuss and debate who and why would want to intervene with trade. Governments. Sometimes governments take action to alter the course of free trade through barriers, and we'll talk about the economic rationale governments use to erect trade barriers, and we'll talk about whether or not these are good or bad economic ideas.